moving on from thinking about zero, positive numbers and negative numbers, we've got to think about odd and even numbers. Now, firstly, we need to think about the properties of addition. If we add two odd numbers, then we're going to get an even number, and we can test this out. If we say 1 plus 1, it's always going to equal 2. And you can think of any two odd numbers that you like and add them together, and you'll find that you always get an even number. Similarly, any two even numbers that are added together are going to give you an even number. And therefore, the only way that you can get an odd number as a result of adding two numbers together is if you add an odd and an even number together. And this works for subtraction as well. So if you see odd plus or minus odd equals even, even plus or minus even equals even, odd plus or minus even is going to give you an odd number. So that's on the addition side. Now thinking about multiplication, an even number times an even number is an even number. 2 times 2 is certainly going to be 4, and that's going to be even. You can think of any two even numbers you like, multiply them, and the result will be even. An odd times an even number, so let's say 3 times 2 is always going to be even. The only way that you can get an odd number as the result of multiplication is if you multiply two odd numbers together. So let's say 3 times 5. Now, that's always going to be odd. One of the ways that's helpful to remember excuse me, these principles of multiplication and oddness and evenness is to think about the significance of a number having a prime factor of 2. If a number is even, then by definition, one of its prime factors is 2. It can be divided evenly by 2. So if a number has a prime factor of 2, then if it's sort of a chain of multiplication, the result of that multiplication is also going to have a prime factor of 2, is also going to be divisible by 2. You could multiply 15 odd numbers together, and the result would be odd, because none of those odd numbers has a prime factor of 2. All of them are not divisible by 2, so the result of multiplying them is not going to be divisible by 2. You could multiply 14 odd numbers together, and then follow that by multiplying by just one even number, and the result would be divisible by 2. It would have a prime factor of 2 in, because whatever the numbers you chose, that series of multiplications would have ended with multiplying by a number that does have a prime factor of 2 and is, in fact, even. So let's have a look at a couple of ways. So this is a good example of what I was talking about at the beginning of the session. These are very simple concepts, but GMAT hangs some quite tricky questions off of them. So let's have a look at a couple more samples. And I'll just open a poll for you. Okay, so answer choices in. And so which of the following can be odd? Well, in these questions where you have 3 Roman statements with Roman numerals by them, and you've got to evaluate those statements, then it can be very helpful to say to yourself, well, which of these is the easiest to identify, to evaluate? It's quite possible, depending on how you attack the question, that you would have thought Roman numeral 3 was the easiest to evaluate. If you're multiplying 13 consecutive integers, well, that means you're multiplying a series of either 6 even and 7 odd integers, or 7 even and 6 odd integers, depending on whether you start with an odd or an even integer. But in either case, you're going to have a good number of even integers in that multiplication, and that multiplication is therefore going to certainly result in an even number, because all you need in a series of multiplication is one even number for the answer to be to certainly be even. So Roman numeral 3 cannot be odd. The product of 13 consecutive integers can never be odd, and therefore we can immediately say, well, it's not answer choice C, it's not answer choice D, and it's not answer choice E, because all of those contain Roman numeral 3. Then we can look at Roman numeral 1, the sum. And then we look at the answer choices that we've got left. We've got A is 2 only, and B is 1 and 2 only. Well, what does that mean? It means that really we can certainly take for granted that that 2 is correct, that the sum of 10 consecutive integers can be odd, because both of the remaining answer choices contain Roman numeral 2. We only need to evaluate Roman numeral 1. So the sum of 7 consecutive integers, well, what's the easiest way to check that? Well, one reasonably easy way to check that is to say to ourselves, well, let's add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And adding those up gives us 10, 15, 21, 28. So that's not going to be that's not odd. But then we can leave out 1 and add 8 and add those up and find that we do get an odd number, and therefore Roman numeral 1 is also correct. It's also possible for it to be odd, and therefore the correct answer is B. Okay. So